Okay, this afternoon, we are looking at rotational motion and gravity. Yeah, we will not so much look at gravity as per se, but the idea of gravity, we'll just hint it, we'll just hint on it, and we'll just give some hints, but we'll dwell muchly on rotational motion, and just look at some of the parameters that describe motion in a circle or motion around the circular path. So let's look at some of the parameters that we are going to be dealing with. Again, you realize that I'm sure you are familiar with linear motion. Even before we look at some of the parameters, even when we look at linear motion is where an object is probably making movements along straight paths. If it is going probably in a certain direction at a certain speed, but it's moving in that direction in ideally a straight path. All right, it's not making round corners. If it's just making sharp corners, if it was moving from the left, then it moves in the other direction. But where an object starts moving in a circular path, then that object will be in rotational motion, and it will experience some certain forces, such as centripetal forces, and a whole new set of parameters start applying to that object in a motion, in that motion. So one thing I can just talk about again on rotational motion is just to talk about Newton's laws of motion. I'm sure you are familiar with Newton's first law, Newton's second law, but the whole idea is that Newton's laws of motion are very much applicable. All right. So when we come to rotational motion, we have to bear in mind that Newton's laws of motion are applicable. So the aspect of acceleration, the aspect of forces, the aspect of whatnot, they are very much applicable. Now, since we are so much used to rotational motion, I mean, we are so much used to linear motion. So I have some parameters that I've written out, which you are familiar with in linear motion. In linear, you know, talks. It's synonymous to straight. When something is straight, we have a straight path. You have something linear, and so when we talk about motion, linear motion, we're talking about straight path, an object moving in a straight path. But when you talk about rotational motion, as I already said, we will be talking about an object moving in a circle, all right, or in a circular path. So we have some parameters that you are familiar with: velocity, displacement velocity, acceleration. Okay, so I can see Chipo has also joined us. Chipo, how are you? Chipo, are you with us? And Mr. Gilbert as well. Mr. Gilbert has joined us, so you are welcome. I hope you are able to hear me. And if you awesome, it has been a while since you were with us. You went away. Okay. Anyway, hope they are able to follow us. Hope Chipo and Wheezy.
The quizzes.
Oh, you have been having quizzes? Anyway, maybe we can chat properly in your inbox to find out why you were not, you have not been attending class. But anyway, we are continuing on. And I just wanted to say that there are some parameters that you have which you are familiar with in linear motion, and these are analogous to.
Yes, I'll be preparing for your quiz.
Okay. Um, Hopefully you are able to hear me loud and clear, and probably we can chat properly at the later stage to find out just why you have not been attending class. Anyway, like I'm saying, we are talking about rotational motion to our friends who have just joined us, and we just want to see how we can help each other understand this concept of rotational motion. And I'm relating rotational motion to linear motion, which you are familiar with. You are familiar with motion in a straight path, where parameters such as distance, velocity, acceleration describe the motion of an object. But then we'll be talking about other parameters that are analogous to these parameters, which are instead of distance in rotational motion, we'll be looking at the change in the angle. All right, the change in the angle. So we'll be looking at this parameter here denoted by theta, but it will be probably the change in angle. It will be something analogous to displacement in the linear motion. And then we will be also talking about, in fact, this one is called angular displacement. So whenever we talk about angular displacement, it's that symbol. And then this is analogous to our displacement in linear motion. And then we also have angular velocity, which is the analogous to velocity in linear motion, and as well as angular acceleration, which is analogous to acceleration in linear motion. So I'll not so much go into describing this because I'm sure even when I was lecturing the other class, the bigger group of campus ministries, when I was lecturing them, we touched on rotational motion, and you guys have been reading stuff on rotational motion, so you are very familiar with it. We'd just like to build on that knowledge that you already have on angular motion or rotational motion. So the parameters are these, all right? So the angle that we're talking about is when an object is moving in a circular path, it will be sweeping across a certain angle. So if it sweeps across a certain angle like this, the angular displacement will be given by this theta. If it again sweeps again across an angle of that nature, it would have swept across this theta. So all in all, what we mean in angular motion is, or rotational motion is, an object is moving in a circular path. Maybe a wheel is rotating, or a car is going about a roundabout. Just a moment. My internet, my Wi-Fi has gone off. Let me switch it on.